So to look at this simplified case, we first erase this area to create some place where I can write my equations. First, I need to define certain variables. One of them being the displacement of the wheel, which I will call x. Second, I will define a coordinate showing the angular position of the mass m, which I call theta. Equipped with this, I can write two equations. The first equation is about the whole system made of this mass, the small mass, the stiffness, the spring, and the dashpot. What I can get is something along the lines of m plus m times xg double dot, when I explain what xg is, must be equal to minus kx minus mu x dot. Now what is xg? It is the location of the CG of the system. Now the CG of the system is located at m times the location x plus small r times cosine theta times small m divided by m plus m. The reason for that is that the location of the center of gravity moves as m rotates around the whole system. Okay. Now we can add the following thing, which is that theta will be equal to omega t, where omega is the angular velocity. Another way of saying it is that theta will be equal to v over r times t, where v is the vehicle speed. Now, under these conditions, I can now write this equation as m x double dot plus r so r d squared dt squared of cosine omega t, so cosine omega t times a small m in front of it is equal to minus kx minus mu x dot. Finally, erasing all this, we can write my mistake. Okay, so let's see what happens when I do this complicated erase pattern. Oh, did a decent job. We get the first equation, which is m x double dot minus m omega square r cosine omega t is equal to minus kx minus mu x dot. Now really, we don't need any other equations because this equation gives us everything we want. Indeed, we can rewrite this equation as follows. We can rewrite this equation as m x double dot plus mu x dot plus k times x is equal to m omega squared, which is v over r squared, times r times cosine v over r t. And so, what we literally have is a system that is excited by this input, and the dynamics of this system is like that. So we know that x of t, well, if we define, first of all, let's define the complex signal that we dealt with before. The complex signal we're going to look at is e to the v over r times t multiplied by j. Okay? Which is cosine v over r times t plus j times cosine j over r. Okay? So what we get is that x will be equal to, as far as steady state component is concerned, it will be equal to 1 over m times j omega squared plus mu times j omega times k plus k, times the amplitude of the input signal, which will be m v squared over r, because one of the r's goes away, times e to the j omega t. Okay, so that's the complex element. Now, if you want just the response to cosine of omega t, which is where omega is v over r, what you do is you just take the real part of this element. Okay, and what do you notice? Well, it's probably easier to use the omega notation rather than the v over r notation. But we get that this is equal to the real part of 1 over m j omega squared plus mu times j omega plus k times small m times omega squared times r times e to the j omega t. So the amplitude of the motion I mean its amplitude is this number here. The rest is really the phase of the signal. And so what we see is that when omega goes to 0, the system really responds with 0 amplitude. When omega goes to infinity, the system goes as far as the amplitude is concerned, it goes like, let me clean up my sheet here. It will go to m times omega squared divided by omega squared. So, let me repeat, m times omega squared divided by omega squared, so it counts for just 1, divided by m. We skip the -1 term, okay, times r. And so the amplitude of the motion goes to some limit, which is proportional to the ratio of the mass of the wheel to the mass of the imbalance term. Okay, think of it as the missing lead component that you often find on the rim of your wheels in your car. So we have these two extreme cases, and in between we're going to have some very interesting response depending on the values of m, mu, and k. We will plot this number, okay, including the omega squared term on top, in the next lecture. Thank you.